I'm Olivia Chapin, and I will be telling you about the hydroxyl, carbonyl, and carboxyl functional groups. Our first functional group will be the hydroxyl group. A hydroxyl group is a functional group found in sugars and alcohols. A hydroxyl group contains one oxygen atom, which is bonded to a hydrogen atom. And this group is polar, and the negative side is always the oxygen and the positive side is always the hydrogen. Ethanol is a perfect example of a hydroxyl group being found in a molecule. Right here is where the oxygen and hydrogen are bonded together, which is the hydroxyl group. And if you didn't know, ethanol is the alcohol which is present in alcoholic beverages. Our next functional group is a carbonyl group. And a carbonyl group is a functional group composed of a carbon atom which is double bonded to an oxygen atom. And the simplest carbonyl groups are usually aldehydes and ketones, which are usually attached to other carbon compounds. These structures can be found in many aromatic compounds which contribute to smell and taste. A perfect example of a carbonyl group being found in a molecule is an acetone. And right here is where the oxygen is double bonded to the carbon. And acetone is the simplest ketone. Now my final functional group is a carboxyl group, which is actually slightly acidic. The carboxyl group is composed of an oxygen atom, double bonded to a carbon atom, which is bonded to another oxygen atom, which is bonded to a hydrogen atom. And it can be found in biological molecules. It's found in amino acids, proteins, fatty acids, acetic acids, and other organic acids. Because the carboxyl group is a weak acid, it will dissociate partially to release hydrogen ions. Now, a perfect example of a carboxyl group being found in a molecule would be an acetic acid, which is the acid that gives vinegar its sour taste. Here you can see the oxygen, which is double bonded to a carbon, which is also bonded to another oxygen, which is bonded to a hydrogen. That makes up the carboxyl group.
I am the mad scientist. Today, I am going to teach you about the phosphate group and the amino group. As you can see, right here, this is a phosphate group. It is very important because its electrons store much energy. That's why it's used three times in ATP. You know, the energy thing inside of our cells. It is also used in our DNA. Just, you know, the little things that code for all of our proteins and whatnot. It's very important. So remember that. Today I'll be covering the amino group. The amino group is one nitrogen single bonded to two hydrogen atoms, shown here. It is the most basic of functional groups, and compound names of the amino group are amine. Two examples of amines are glycine and methylamine. Yeah, as you can see here, the amino group is here, glycine, and here, and methylamine. It is also important to note that the nitrogen can be single bonded to a hydrogen or a carbon. And these two examples I've given you, the nitrogen is single bonded to a carbon. See? Nitrogen or carbon. But it can also be to another hydrogen. However, if it is double bonded to carbon, it is not an amino. It's not an amine, it's double bonded. It has to be single bonded to the carbon. And also
Hello, my name is Sherlock Holmes. My initials are SH, just like a functional group called the sulfhydryl group. It has a sulfur bonded to hydrogen and is found in other molecules. One of its main functions is to make your hair look great. For example, look at mine. The way it holds its curls, that's because of the sulfhydryl. To change the shape of your hair, you have to heat it up and break the bonds. That is why straighteners and curlers are heated. This group over here is the methyl group. Its two functions are related to genetics. It affects sex hormones and how genes are expressed. It has one carbon bonded to 3 hydrogens, and the squiggly type line over here you see means it can be bonded to anything else that requires 2 valence electrons. And an example of something that this is found in is methyl alcohol. Other alcohols are likely to contain 2.